Guys, this is the new video for differential equations, and in that video I'm going to talk about the solving procedures. So first of all, in this video I'm going to talk about the variable separable method. Now what is variable separable method? So in variable, the format of variable separable method is something like that, where p is the function of x, okay, or a constant. Well, as same as for q is a function of y or a constant. This is the form of variable separable. In that case, you just have to do a simple thing. You just have to integrate both side. Integrate both side, something like px, not px actually, this is p dx is equals to q dy plus c. Now c, what is c? C is the indefinite integral constant, IIC, indefinite integral constant. Well, after integration you will get the solution of this equation. So let's do some examples. This is, let's say, e to the power x plus y is equals to dy by dx. In that case we have to make this equation, we have to convert this equation into that format so that I can use the integration. So in that case, how we can proceed? It's very easy. So this is e to the power x into e to the power y is equals to what? Dy by dx. Now this is nothing but e to the power x into dx is equals to e to the power minus y into dy. Right? Very easily you can understand. Now I have to integrate both sides. This is the function of x with dx and this is the function of y with dy. It's an exponential function. Now plus c. What is c? C is the indefinite integral constant. Integration of e to the power x is e to the power x. Integration of e to the power minus y is to the power minus y plus c. So the solution is something like that. E to the power x plus e to the power y, not y actually, minus y, is equals to c. Well, this is the solution of this equation, this differential equation. Hopefully it is visible to you that how I can solve this equation. Now let's talk about another example so that you can understand it more carefully. So basically, let's say this is dy by dx is equals to ky. Well, in that case, how we can proceed? Well, this is dy. We have to convert it into that format, p into dx equals to q into dy. So this is dy. I am taking the y from the right side to left side. This is dy by dy is equals to what? K into dx. Right, now I have to integrate both sides. After integration I have to add a constant, and integration of 1 by y is what? Ln y is equals to constant, which is k, into x. Integration of dx is x plus c. Now this is the solution of this differential equation. Now you can simplify further, like this is y is equals to e to the power kx plus c. Right? So you can understand, right? Now some of the cases examiner will provide you a initial condition or boundary condition. What are the initial and what is the difference between boundary condition and initial condition? In initial condition, you will deal with time, t, dx by dt or dy by dt. T is given, right? But in case of like x, y or z or something like that, they are representing the displacement. So the condition will be boundary condition. Now why the name is boundary and why the name is initial? Because they will give you the t0. Y at t0 will be something like y0. So t0 means the initial position, but when they will give you the x0, which is nothing but the representation of displacement, then x0 means displacement has a boundary, right? So that's why this is called the boundary condition, and this is called and this is called the initial condition. Hopefully you can understand. This is y0. Now in that case, let's say examiner will give you some kind of boundary condition, which is, it is boundary condition because t is not mentioned, time is not given to the question. So it's very simple. Now let's say this is y is equals to c. Wait, this is not c, this is, let's say, a. Now in that case, ya is equals to a. That means when x is equals to a, then we can say that y is also equals to a. Now we can simplify the equation more after getting the boundary condition, because we can evaluate the c, the integral constant here. Now when x is equals to a, then y is equals to a. So a is equals to e to the power what, ax, not ax, sorry, this is ka plus c. Very nice. Now this will be something like ln a is equals to ka plus c. Now c will be what, ln a minus, wait, ka, right? This is the value of c. This is the value of c. Now we have to replace the c here, right? We have to replace the c here so that we can get a like very simplified equation. This is y is equals to e to the power ka plus the value of c is what, ln a minus ka. Wait, this is not a, this is x actually, sorry. Now it is very easy, right? Now what will happen, this ln a is like e to the power ln a into e to the power k into x minus a, right? So this will be a into e to the power k into x minus a, and this is y. So this is the final solution of this differential equation if examiner will provide you any kind of boundary condition here. Not initial condition, because t is not mentioned, time is not given, x and y and z all are the representation of displacement, and displacement is a kind of boundary condition, like displacement has a boundary. So that is all about today's video. In the next video I will talk about some more formats of variable separable, where you will deal with some kind of homogeneous equations, you will deal with some kind of like not replaceable, actually it is like reducible to variable separable, something like very hypothetical format will be given to you and you have to convert it into variable separable somehow. And homogeneous also, in homogeneous we will talk about a kind of replacement y is equals to vx or x equals to vy, and we will talk about the reversing of differential coefficient in that. Wait a moment. So in the next video we will talk about some kind of reversing the differential coefficient, like dy by dx is equals to 1 by dx by dy, right? Because in some of the cases you will see, like if we are reversing, if we are using the reciprocal of the differential coefficient, then we will be able to solve the equation or differential equation very easily. So that is all about today's video. Thank you for watching my videos and keep learning. Goodbye.